For the last section of chapter 11.5, we just kind of want to put it all together, everything that we've done so far. You'll notice, by the way, that we skipped section 11.4. That's because it's much trickier and it introduces a whole new distribution called the F distribution that we just don't want to deal with. So, all right, let's talk about section 11.2. What did we learn there? We learned about testing mu with dependent sampling. So when you want to have a test or an interval for mu with dependent, remember, paired samples. All right, so if you remember, that means we're using the t-test, just the regular old t-test, but it's of the differences rather than the actual values. So that was, let me find the test right here. It's the paired t-test. So your hypotheses always have 0, and then your null hypothesis, and then your alternative is always less than 0, greater than 0, or not equal to 0. But you're using d bar and sd for differences rather than using x bar and s, which we did in chapter 10. Now it's just a regular t-test, and if you're making the interval, it's just a regular t-interval. So let me clear this out. So you would go to stat, you would go to tests, and you would pick number 2 for t-test if you're making a test, or number 8 for interval if you're making an interval. There, those two. So they're actually very, very similar to what you did in chapter 10. It's just that it's differences now for pairs instead of individuals like it was in chapter 10. Okay, so you'd use that t-test, and then you'd follow along this approach, right? The same steps we're used to. This is the one that gets the little d's after it because of the paired. That's the only one that gets the little d's for difference. The other two that involve subtraction don't get the little d's because they're not paired differences like they are for this test. Just a reminder as well, on the front page of your inferential statistics sheet, you can see, there it is. There's the t-interval that we're talking about right here. So that's the one for 11.2. All right, then for 11.3, we had this one right here, which was for independent samples. So you're still talking about the mean, but you're talking about independent samples. So that would be section 11.3 right here. That's the 2-samp t-test. That's a much more complicated thing to enter into the calculator. So if I grab the 2-samp t-test, I didn't bother showing you the calculator for regular t-test because it's what you already learned in chapter 10. But the 2-sample one's got a whole bunch of information you got to put in there, right? So tons of info if you're going to use stats. So you got to tell it x bar 1, s1, n1, x bar 2, s2, n2. Then you have to choose your hypotheses, your alternative hypothesis. Then always remember that we always have pooled no in this class. And then you go down to calculate. Okay, so that's the 2-samp t-test. The 2-samp t-interval, oh, wait, at the very top, if you had data, if you had 2 columns worth of data, you could do a data set where one data set's in L1 and one data set's in L2. We always leave frequencies as 1, always. And then again, you have to choose your alternative hypothesis. So use your arrow keys to move around, don't use your enter key. And then always leave pooled as no. All right, so that's 2-samp t-test. 2-samp t-interval is actually very similar to that. It's number 0. I'm pretty sure. There it is, 2-samp t-int. So again, it has the data option, but down here you can choose your confidence level, and again, always leave pooled no. If you have stats instead of data, right, data is when you have a column of raw data given to you. But if you don't have that and they just give you information like x bar was this, standard deviation was this, then you'd have to type it all in yourself, and then your confidence level, and then leave pooled no and go down to calculate. So extremely similar to the test, but not exactly the same. So just to recap so far, the paired ones, you use number 2 or number 8. Right, the t-test or the t-interval. They're very basic because you're already working with differences, and that's just one column of difference data. So you'd use d bar here, sd here, and n. Okay. Then when it's independent means, that's when you start getting into the 2-samp t-test, which is number 4, which has this very complicated entry system because you have to put in stuff for one sample and then for the other sample. And then always leave pooled no. Or you have the 2-samp t-int, which is number 0. I'm just going to press 0. There it is. Very, very similar. And then you always have data as an option, but that only works if you have data given to you in the problem. Okay, so that'll be how you use the calculator to come up with the interval or the test. The test is up here, 2samp t-test. The interval is right down here, 2samp t-interval. And again, you don't have to put these on your note sheets because they're already on the inferential statistics sheet right here. 2samp t-int, that's this one, that's for 2 sample means independent samples, as opposed to dependent samples, which is this one. All right, so that's that for 11.3, I believe. Then what about 11.1? What about proportions? Oh, and we didn't do dependent sampling. You can actually just ignore this because it's not on the calculator and I cut it from the assignments for this semester, so it's gone. All right, so look at the testing for proportions with independent sampling. That's the only kind we did. All right, that uses the z distribution. You can tell it uses the z distribution a lot of ways, but one of the ways you can spot it is when you look at the interval, it uses a z. See that right there? Or when you look at the test, let me grab the test. Here's the test. It says 2 prop z test. See? It's a z distribution. Z is your test statistic. As opposed to the ones for means right here where t was your test statistic. That's why you could tell this was a t distribution because it's a t test, right? Whereas this one is a z test. Oh, I forgot to mention real quick, I'm sorry. The degrees of freedom for that first type is really simple. It's just n-1. And this is the one with the horrible degrees of freedom that we kind of ignore because it's so hard we just make computers figure it out for us. Sorry, I forgot about that. Of course, with a z distribution, you don't have to worry about a degrees of freedom because there isn't one. It's the z distribution. It is what it is, right? The mean is 0. The standard deviation is 1. And for that one, you're going to use a 2 prop z test, or when you're doing the interval, a 2 prop z interval. Okay, so let me show you those real quick. The 2 prop z test. So if I go to stat, tests, 2 prop z test is number 6. Okay, as opposed to 1 prop z test, by the way. 1 prop z test was for a single proportion. That was chapter 9 or chapter 10. When you're dealing with one sample, men have an average lifespan of 75, whatever. Number 6 is, do men and women have different lifespans? Stuff like that. Although actually proportions, it'd be, do men and women have different beliefs about something? Because it's proportions. Lifespans would be sample t-tests. Right, so number 6 is what you'd be using right here. So you choose that, and then you put in your x1, your n1, your x2, your n2. Remember that those have to be whole numbers. If they're not whole numbers, you can't put them in. And then you go down to calculate and press enter. And it runs the whole test. There's your z-score, there's your p-value, etc. If you run an interval, that's closer to the bottom, if I'm not mistaken. There it is. It's letter B. It's the 2 prop z interval. So it's very similar in terms of input, x1, n1, x2, n2, and then you tell it your confidence level and press enter, and you find it. Notice, by the way, it gives you your P1 hat and P2 hat if you didn't know that already. And when you get lost and you can't remember which one to use, remember, it's always on the inferential statistics sheet right here. It tells you right at the top which one to use. 2samp t-test, 2 prop z-test, stuff like that. So one other thing to note, a couple things to note real quickly. We've learned all of these intervals. We've learned all of these different tests. So that means that we are now at 6 different tests so far and 6 different confidence intervals total. If I look at the front page of the inferential statistics sheet, right here. So we've learned 6 different confidence intervals. We've learned 6 different hypothesis tests so far, and there's more coming. So you're going to have to really pay attention to the writing and figure out which one they're talking about. And that's where that other piece of information comes in handy. Here it is. Paying attention to, what are you talking about? Are you testing mu? Right? If you're testing the mean, then that's one thing. Is it dependent? That's going to tell you which type of test this is. If it's the mu and it's independent, that's a different kind of test. So you're going to have to read very, very carefully to know which kind was I doing. Was it a mean for a dependent? Was it a mean for independent? What was going on? Then for proportions, In general, if it feels like you're not being given enough info, that's usually a proportion problem because they don't have to give you nearly as much with proportions as they do with the other kind. Okay, so if you feel like you're testing proportions, if they start talking about percentages all over the place, that's a proportion test. So you'll have to pay really close attention to know which problem you're doing when. Similarly, with sample size formulas, we have 2 more now of those. So now that gives us 5 sample size formulas altogether. So you're going to have to pay really close attention to know which sample size formula you're using because they're all slightly different from each other. So you have to think, okay, am I doing 1 sample or 2 samples? 1 sample are these ones, 2 samples are these ones. If I'm not doing a sample proportion at all, if they're not proportions, that's this one. So that one's kind of the easiest one to spot. If they're talking about average or mean, this is the only one. If they say, how many people do you need? That's this one, right, for a mean. But for proportions, you have 4 options. So you have to think, is it talking about one group? Do I want to go get men, women? Or do I want to get men and women and compare the two? That's these two. Similarly, am I making a confidence interval for men and women? That'd be one of these two. If it's husbands and wives, that's this one. And then these are all the single sample ones that we learned in chapter 9. The only one for variance or standard deviation we've ever learned are these two, so that's kind of obvious. If they say construct a confidence interval for standard deviation, it's got to be this one right here. If they say construct a confidence interval for variance, that's that one, no question about it. But if they talk about proportions, you have to pay attention. Are they talking about a single proportion? Because that's one prop z-int. Or are they talking about comparing 2 groups' proportions? That's 2 prop z-int. And they're talking about 1 mean or 2 means. So if it's 1 mean, that's t-interval. If it's 2 means, it depends. If it's dependent, then it's t-interval, but with the differences, d. And if it's 2 samples, 2 independent samples, but they're independent of each other, right? I think I said that, independent of each other, that would be 2 samp t int. You're going to have to pay really close attention to figure out which one you're using when. All right. We are all done with chapter 11. With that, you've been given your word of warning to take a highlighter and pay very close attention to, are we talking about means? Are we talking about proportions? Is it 1 sample? Is it 2 sample? What are we doing? Because unless you know what you're doing, you can't use the right formula, etc. A couple other notes. If you try to use a formula and you find you don't have enough info for it, or you find you have too much info for it, that might be a sign you picked the wrong formula. Also, in chapters 10 and 11, if you have a p-value that's really high, say like 0.99 or something like that, that's usually a red flag that you chose the wrong direction in your alternative hypothesis in your calculator. So when you choose down here, if you have a number that's really, really high, that's usually a sign that you picked the wrong thing down here. So let me show you. Let me see if it'll do it. Yeah, 0.9995. See that? That's the wrong direction. When that happens with your p-value in chapters 10 and 11, this might not be the case in 12 and 13, but in chapters 10 and 11, if that happens, that is usually a red flag that you should have gone the other direction. This wasn't a greater than, it was a less than for your alternative hypothesis. All right, I think we're all done with chapter 11. I'll see you back here for chapter 12.